This is a very short overview of what the engine does, starting from main.run. Let's go. So, first thing we do, try except on initiating a window. In that, we have it initiating the window, checking some game directory stuff, making sure it can actually load everything it needs to. Then we set up an error callback, so if anything goes wrong, we can print those out, and hopefully let me debug some things. There's a lot of those. Then we have just a quick init function for GLFW. All of this stuff is window hints that basically says whether it's like hidden or not hidden. You can resize it. Should it automatically be focused? I am never focused. We set the width to a pretty much arbitrary value that just looked nice on my screen. Have the title, have the width, the height. I'm not sure what those do, but I remember keeping them null did me pretty good, so that's nice. If the window ends up being null when we create it, though, that's a failure. We close the program, give me an error. I go bug fix for a couple hours. Keyboard, mouse. We have all of this memory stuff, so we can actually create buffers and push frames. We make the current OpenGL context the current window, and we enable VSync because that looks nice. We have the render system set up here, and then we have the camera go right after it, and then we show the window. Next up, if we go back to run, we have the game loop next. Now this is where everything happens, and everything can also go wrong. It's where we call everything, and all the nice stuff. We reset the clock so that we can have an accurate count for our FPS. We start the game loop. I printed that for some reason at some point. I was having trouble with calling functions. We don't really talk about that. I've gotten better since then. Probably. Point is, GL create capabilities. Basically what this means is we are showing OpenGL what this device can do and what workarounds it has to use. Clear color. This is a background color. Set it to anything you want. For example, it looks terrible. That's why I keep it black. It looks good, mostly. Then we set up the frame buffer callback so that we can continue rendering things, and also this scales everything in the window so that on resize things don't just snap weirdly. So this actually took me a second to get working. I clicked the wrong thing. Basically, things scale now. That didn't used to happen. It was really annoying. We create the values for the last time the ticks were updated or the frames were updated. Try and accept for the getting of all the startup things, and we get all the game loop runnable things. There are 3 annotations basically. I only use one of them in the example because that's all I need to use. If you wanted to do more, you could have something there, and then you could have the annotation of game loop, which is right here, and that would run in the game loop every tick. These do happen after game object components are called, so if you have any scripts that you want to go before that, make sure to attach them to game objects. The tick loop is pretty simple. All we do is every 30 times a second, update the keyboard, update the mouse, set game object last positions for rendering, and set components and update all those. Game loop runnables, TPS count. And this is the last update time, so we know when we should do another game tick. This is a frame thing. This makes it look simple. The render system is not simple. It's overly complex for no reason because it's complex on the inside, easy on the outside. I'll show you in a second. FPS count, you know what that does. And frame last update time, same thing as this. We want to keep track and keep it as a steady 60. Now let's dive into that rendering system a little bit. we start out at the render dispatcher. Now this is the most important part. This is where we clear the frame buffer. We set up the camera. Use the first thing we activate in the matrix modes is projection to set up the camera. Clear the matrix. Enable, not like, I did the X-Files scene. You get my point. Not like the matrix, yo, but like a math matrix. You guys know what I mean. We enable culling face, so that basically says if the face of the model, right, you don't want to be drawing the back sides of things if you don't need to, which is exactly what that does. We cull the back face. And then the depth test, that is how we make sure that things get drawn by depth and not what order they are in the rendering. This is the important thing. This is 2D versus 3D. This is 2D mode. We've got GL12, GL ortho. We're setting that to just current width by current height, far plane -1, near plane 0, all that good stuff. I don't know what anything here does. If you ask me, I could not provide a response. I genuinely do not know what anything in that function does, but it works because I got a pretty terrible Minecraft clone running at one point. This is just setting up the model render instead of setting up how the projection works. And then we enable texture 2D so that we can draw 2D textures. Yes, it specifies 2D. I learned when I was adding this that there is such thing as 1D textures and 3D textures. I don't know why. Then we have just the callback loop of every game object in the scene, render it. And then after that, we swap the buffers, which is basically saying there's the buffer on the screen and the back buffer. And essentially, the back buffer is where you draw all the things and then you swap them, and that switches the back buffer onto the screen. So you see that frame, and then you clear what was previously the front buffer, but now that's the back buffer, right? That's not the one showing. And you clear that, you draw all the things again, and you just switch it again. You clear it, switch it, draw all the things in between. That's basically how this works. This is where things get a little iffy, right? So this render function on every game object, that's highly variable. This is set up for a GL12 implementation. But technically, I think with this, you could set up shaders and stuff. I don't think so. Maybe. Do I think so? I need to do more research on that. We might have to recode all this later. Point is, this is where things get rendered. This is where things can either go wrong or it's where the magic happens. Now I have two examples of ways of rendering things today. We've got the textured quad and the other textured quad. Yippee. Very, very different. It's still a good example though, since most textures are, rectangle. So that's a nice analogous thing to have. Starting with quad 2, because that's this one you're seeing. It's the Minecraft dirt block with all the fancy rainbow colors on it, not the UV map. I'll talk about that later. Now this textured quad 2, also known as Minecraft dirt block, it's pretty simple. We're setting up a draw builder, but then we're rendering a model. Now, I don't have support for things like OBJ or like FBX, I don't know. Those are too complex. I don't want to deal with that. They have things called normals, which is basically what makes sure that you're doing the cull face thing, right? And you can also have lighting with those. Lighting is for noobs. Who needs lighting? So I can't load anything but the godly .josh file. This is absolutely amazing. It's the best file ever created. Let me show you how it works. We got the model reader. Now we open a text file. and we go through line by line. The first line is the GL draw mode. So essentially, this saying 7 up here is saying we're drawing this as GL quads, because quad, 4 vertices. And then we specify what texture it's going to pull from the texture preloader. So in that case, this is dirt, and because of how the texture preloader does things, that basically just keeps it to the file name. So you can't have dirt.jpg and dirt.png, and they're different things. Can't do that. Sorry, guys. Point is, that's loading this. And then we have each pair of 3 coordinates. This is the XYZ of everything. Note that this actually does later get added to the actual XYZ of the game object. This is just basically how far it is from the center. This is 0, because 2D, the z-axis can be 0. We've got -50, -50. We're doing the bottom left corner first. And then we do the bottom right corner, top right corner, and finally the top left corner. That took me a second, and I'm not sure how to feel about that. This 0 is pretty much redundant again because this is 2D. It's just there so this model works with 3D. Then we have the color after this. This is red. We've got 1.0 on RGB, on R for RGB, then 0 blue, 0 green, and 1 alpha. Things can be transparent. I'm not sure if that actually fully works yet. It might not. This is blue, this is green, and this is white. And then these are the texture coordinates. This is how it knows that certain parts of the texture go in certain places. So essentially, this bottom left corner, right, the first one drawn, is red, right, and that's showing 0, 0 down here. And then we have 1, 0, which is over here. That's basically saying the right edge of the texture. This is from 1 to 0. And then we go to 1, 1, which is up here. I should probably be showing this with my mouse. I was just pointing to my screen. But 0, 0, 1, 0, 1, 1, 0, 1. We have this nice other textured square to show off exactly how that works. And that's essentially how the rendering system works for models. Now, what's happening behind the scenes, parsing this, we're turning this into a Josh model, which then, if we open that, we have the vertices, the texture name, the texture ID, and the GL mode. Then we get the draw builder command through this function. We're putting in the position and last position, and we're getting the commands needed to draw this to the screen. Then we have a different way of doing things on this one. I just forgot to tell you guys about this. This does the time essentially, so you can interpolate between ticks. Because if your ticks per second is 30 and you're just keeping the same thing, even though you're drawing 60 frames per second, it will look like 30, which is what I had trouble with for a while, but I finally figured it out, and I just needed 1 or 2 lines of code. It's really, really sad, actually. It took me Hi, buddy! Hey, I'm explaining a game engine right now. And then we have the model's draw builder commands. This I just showed you. And that's essentially how this works. All the draw builder does is it takes all those commands and it runs exactly what's inside these, like the bind texture command. It just has the GL12 binding for bind texture. This is just setting up a vertice. And yeah, that's all those do. The draw builder just goes through and executes those. And now here's another way of doing things. This is essentially what this looks like behind the scenes, but I have all this nice code here to do the vertices for me. So we do the same things at the start. We unbind previous textures, we bind the current texture, and then we do GL begin, which is start drawing. We push a vertice, db.next is basically a way of saying, hey, draw builder, give me an empty vertice to work with. Or not vertice. Give me an empty vertex to work. How many times have I said vertice? I hate plurals sometimes. It doesn't make sense. Anyway. Position. We do that. Last position, again for interpolation, so you can have like 30 ticks per second and 60 frames per second, and it doesn't look like 30 ticks per second is the frame rate. And then we do the same UV thing, or texture coordinates, right? And then this essentially does the exact same thing without the fancy RGB effect on top of the dirt block. This is just this. And then GL end, unbind textures, so we're nice to the next thing being drawn and don't have to deal with... I don't want to talk about what happened previously, that didn't go too well. And then render it out. That's essentially the render system. Nothing else is too interesting, it's just a ton of boring stuff that took too long to make. We have a GLFW key callback. That just sends key actions to a list, and the isKeyDown function just tells you, is this key down? If so, do something. That doesn't seem like it's very useful. It seems like, oh, but what if I want to on-key press? First off, GLFW. Second, what you can do is you can take a version of this from the previous update and compare the two, then take one from the previous update and compare the two, and basically just use that to get anything else. Like, for example, if you want to get on key down, on key up, how long is this key been pressed for a while, right? That you can just compare previous versions of this. I don't have built-in features for that, but it should be easy to implement, so I trust in people doing things. Probably a bad idea. This is a mouse handler. Not everything here is actually complete. I need to just add a click callback, and that'll be it. I think I might do that in a bit, but all it does right now is gives you a cursor position, which I need to fix. Anyway, that's essentially my entire game engine. All I've forgotten to go over really is the camera, but I'm sure nobody wants me to talk about all the crappy rotation math and stuff with Matrix, and I hate it, kind of. It's fun when you're done, though. It's fun to have a game engine. It's never fun to make one. I take that back. This is really fun to make.